You can tap the second service transformer to establish a third service for the building addition, provided several conditions are satisfied. The second service transformer must possess ample spare capacity to handle the additional load imposed by the new addition, and the review of the past 12 months of electrical billing statements has shown that this condition is met. Compliance with Article 230 of the National Electrical Code, or NEC, is mandatory when implementing multiple services. Each individual service is limited to a maximum of 6 disconnect switches. In this particular scenario, the existing second service already features 6 circuit breakers within its distribution section, which inherently fulfills this requirement. The service disconnect dedicated to the third service can be strategically positioned at a distance from the 3000 amp switchboard that is associated with the second service. Several sections of the NEC bear directly on this type of installation. NEC Section 230.1 specifies that a single overhead service supply can comprise one or more service drops, and each service drop must have a service disconnect located at the building or structure it serves. NEC Section 230.11 addresses underground service supplies, stating that a single underground service can consist of one or more service laterals, with each lateral feeding a separate service. NEC Section 230.12 permits multiple services to a single building under specific conditions. Each service must be equipped with its own separate service disconnecting means, and unmetered services cannot be combined with metered services. NEC Section 230.15 allows each service disconnecting means to serve as the sole means of disconnecting one or more service conductors. There are also several additional factors to bear in mind. The new service disconnect designed for the building addition must be clearly and accurately labeled. It is very likely that the local electrical authority will mandate a permit for the installation of the additional service. It is highly recommended that you seek guidance from a qualified electrician to guarantee that all electrical work adheres strictly to both the National Electrical Code and any applicable local regulations. A deeper exploration of the NEC reveals further stipulations and considerations that are relevant to your project. Article 230 covers service entrances, addressing requirements for both overhead and underground service conductors. These requirements ensure that the service entrance is installed safely and correctly. When planning your third service, conductor sizing is critical. NEC Section 310.15 provides guidance on determining the ampacity of conductors based on factors like insulation type, temperature rating, and the number of current carrying conductors in a raceway. Correct conductor sizing prevents overheating and potential fire hazards. Overcurrent protection is another essential aspect. NEC Article 240 details the requirements for overcurrent protective devices such as circuit breakers and fuses. These devices protect the electrical system from overloads and short circuits, preventing damage to equipment and ensuring safety. Grounding and bonding are vital for electrical safety. NEC Article 250 outlines the requirements for grounding and bonding electrical systems. Proper grounding and bonding provide a low impedance path for fault currents, helping to trip over current protective devices and minimize the risk of electric shock. Service equipment must be readily accessible. NEC Section 230.70 requires that service disconnecting means be readily accessible, meaning they must be located where they can be easily reached without obstruction. This ensures that the service can be quickly disconnected in an emergency. The height of service conductors above ground is also regulated. NEC Section 230.24 specifies the minimum required clearance for overhead service conductors above ground, roadways, and other areas. These clearances prevent accidental contact with the conductors. Service entrances must be protected from physical damage. NEC Section 230.50 requires that service entrance conductors be protected from physical damage by using raceways, enclosures, or other suitable means. This protection prevents damage to the conductors that could lead to electrical hazards. The NEC also addresses the use of surge protection devices. NEC Section 230.67 requires surge protection devices to be installed in certain service entrances to protect against voltage surges caused by lightning or other events. These devices help to prevent damage to sensitive electronic equipment. When multiple services are installed in a building, proper coordination is essential. This coordination involves ensuring that the overcurrent protective devices for each service are sized and coordinated to prevent nuisance tripping and ensure that the electrical system operates safely and reliably. The NEC provides tables and examples to aid in this coordination. In addition to the NEC, local electrical codes may impose additional requirements or restrictions. It's important to consult with the local electrical authority to determine any specific requirements that apply to your project. These local codes may address issues such as the type of wiring methods allowed, the location of service equipment, and the requirements for inspections. The local utility company may also have specific requirements for connecting the new service to the grid. You will need to coordinate with the utility company to ensure that the new service meets their requirements and that the connection is made safely and reliably. This coordination may involve submitting plans, obtaining approvals, and scheduling inspections. Remember that electrical work can be dangerous, and it's essential to take precautions to protect yourself and others. Always disconnect power before working on electrical equipment. Use appropriate personal protective equipment such as gloves and eye protection, and follow safe work practices. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the work. In addition to the technical aspects of the installation, consider the aesthetic impact of the new service equipment. Choose equipment that is visually appealing and that blends in with the surrounding environment. Consider the location of the service equipment to minimize its visibility and to avoid obstructing access to other areas of the building. Regular inspections and maintenance are essential for ensuring the continued safe and reliable operation of the electrical system. Schedule regular inspections by a qualified electrician to identify and address any potential problems before they become serious. Perform routine maintenance tasks such as cleaning equipment, tightening connections, and testing overcurrent protective devices. Keep accurate records of all inspections, maintenance, and repairs. These records can be helpful for troubleshooting problems and for demonstrating compliance with codes and regulations. When planning the third service, consider the potential for future expansion. Design the system to accommodate future increases in electrical load. This may involve installing larger service conductors, using a larger service disconnect, and providing spare capacity in the distribution panel. Planning for future expansion can save time and money in the long run. Finally, remember that electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to the NEC and local electrical codes. Attend continuing education courses, read industry publications, and participate in professional organizations. Staying informed about the latest codes and regulations is essential for ensuring that your electrical work is safe, compliant, and reliable. In summary, adding a third electrical service to an industrial building is a complex project that requires careful planning and execution. By following the requirements of the NEC, consulting with qualified professionals, and taking appropriate safety precautions, you can ensure that the new service is installed safely, reliably, and in compliance with all applicable codes and regulations. Keep in mind the long-term implications of the new service on the building's electrical system, and plan for future expansion and maintenance. By taking a comprehensive approach to the project, you can ensure that the new service will meet the building's electrical needs for years to come. Let's reiterate the key factors for adding this service. Firstly, confirm adequate transformer capacity from the existing second service. This involves analyzing electrical bills to verify spare capacity for the addition's load. Secondly, strictly adhere to NEC Article 230, which governs multiple electrical services to a single building, focusing on sections regarding service drops, laterals, and disconnecting means. Thirdly, understand and comply with the 6 disconnect rule, ensuring the existing service and new addition stay within the limit of 6 disconnects each. Fourthly, plan the location of the new service disconnect considering accessibility and distance from existing equipment while adhering to NEC guidelines. Fifthly, pay close attention to NEC sections 230.1, 230.11, 230.12, and 230.15 for specific requirements on service types, supply configurations, and disconnecting means. Sixthly, ensure proper labeling of the new service disconnect for easy identification and safety. Seventhly, obtain necessary permits from the local electrical authority before commencing any work. Eighthly, consult with a qualified electrician to ensure all work aligns with NEC and local codes for safety and compliance. Ninthly, verify correct conductor sizing according to NEC section 310.15 to prevent overheating and ensure safe current carrying capacity. Tenthly, implement appropriate overcurrent protection using circuit breakers or fuses as detailed in NEC Article 240 to safeguard against overloads and short circuits. 11th, ensure robust grounding and bonding practices as per NEC Article 250 to establish a low impedance path for fault currents. 12th, guarantee that the service equipment is readily accessible as mandated by NEC Section 230.7T for emergency disconnection. 13th, maintain required clearances for service conductors as stipulated in NEC Section 230.24 to prevent accidental contact. 14th, provide adequate protection against physical damage to service entrance conductors as required by NEC Section 230.50. 15th, consider installing surge protection devices as per NEC Section 230.67 to protect against voltage surges. 16th, coordinate overcurrent protection devices for all services to prevent nuisance tripping and ensure reliable operation. 17th, stay informed about the latest updates to the NEC and local electrical codes to ensure ongoing compliance and safety. 18th, document all inspections, maintenance, and repairs for future reference and compliance verification. 19th, design the system with consideration for future expansion to accommodate increased electrical loads. And 20th, prioritize safety during all phases of the project, using appropriate personal protective equipment and following safe work practices. By diligently addressing these factors, adding a third electrical service can be executed safely, efficiently, and in full compliance with applicable codes and regulations.